Hello and thank you for watching. In this video we're going to go through some polynomial examples of the epsilon-delta definition. So jumping right in, let's start with proving that the limit as x approaches 3 of x squared is equal to 9. Okay, so recalling our definition, we're trying to show that if we have this, then this implies that x squared, the modulus of x squared minus 9 is less than epsilon. Okay, so first thing we should notice is that, okay, we have difference of two squares here, so clearly this is the same as having x minus 3 times x plus 3 less than epsilon. Okay, so now we see that, okay, this matches up, but now we just need to find some way of getting the modulus of x plus 3. So what we can do in this case is think, okay, so what if we say that delta is less than 1, for example? And we can do this because if delta is less than 1, then clearly for any epsilon, if this holds, then this still holds. If we have an epsilon really small, then delta will also be really small, presumably at least, and so it will be less than 1. So under this assumption, if delta is less than 1, then we have that the modulus of x minus 3 is less than 1. Okay, and so what we can do is expand this, so we have that, well, I guess we have a minus 1 here, but then that doesn't matter. And so we have that 6 is less than x plus 3 less than 7. Okay, so from this we can tell that the modulus of x plus 3 is less than 7. We have this 6 here as well, but we don't really care about the 6, we just know that the modulus of x plus 3 is less than the modulus of 7, which is true because both 6 and 7 are positive numbers, so we don't have to worry about any signs. Okay, so from this we know that if delta is less than 1, then the modulus of x plus 3 is less than 7. But what if delta isn't less than 1? Because we made this assumption, because this will give us a delta equal to epsilon over 7, but this is under the assumption that delta is less than 1. So what if delta is not less than 1? This is why we set delta equal to the minimum value of 1 and epsilon over 7. Okay, and this 1 purely stems from this, so if we made the assumption that delta is less than 2, then we'd have that delta is the minimum of 2 and some function of epsilon. But okay, we're sticking with this because we use delta is less than 1. However, if we use this, the proof would be the exact same. Okay, so stemming from this, we can start our proof. So proof. Suppose that epsilon is greater than 0, then if we have the modulus of x minus 3 being less than delta, then x squared minus 9 is less than epsilon. So choose delta to equal to the minimum between 1 and epsilon over 7. Okay, so from here we say, okay, so this is the minimum between 1 and epsilon over 7. So now if we multiply this whole thing by the modulus of x plus 3, we get that x minus 3 and x plus 3 is less than this delta, which is epsilon over 7, and then we figured out before that this is just this has to be less than 7, so we multiply by 7, and so we get that x squared minus 9, the modulus of x squared minus 9 is less than epsilon, and this is what we're looking for. So that's our proof concluded. So moving on to the second example, which is slightly different but similar, we'll have the limit as x goes to 2 of x cubed, and we're going to prove that it goes to 8. Okay, so once more, starting from definition, we have modulus of x minus 2 is less than delta, and we also have that the modulus of x cubed minus 8 is less than epsilon. Okay, so from here we know that x cubed minus 8 is the same as x minus 2 multiplied by x squared plus 2x plus 4. Oh, plus 4. You can multiply this out to check. However, in general, we have that if we have some x to the n minus some y to the n, this is the same as writing x to the n minus 1 plus y to the, well, plus y x and minus 2 plus, and then it's kind of like symmetric in a way, I guess. So at the end we will have xy. Y to the n minus 2 times x plus y to the n minus 1. And this is all multiplied by x minus 1. You can prove this inductively if you wish. You may prove this another way. However, this is true. This is a true statement. So we have that. So we have that x minus 2 times the modulus of x squared plus 2x plus 4 is less than epsilon. Okay, so this is good news. We have this here, these match. So now we just need to find some sort of value for the modulus of x squared plus 2x plus 4. So now we're thinking, okay, so if we set delta to be less than 1 again, then we can do a similar approach. However, this time, if we have 0 x minus 2 less than 1, and then we also have that 0 less than x minus 2, which is less than 1, and so we have that 2 is less than x, which is less than 3. Okay, so notice how before, when we were looking here, we were trying to attain this value. We were trying to get it to be in the same form. However, this time it might be a little bit hard because we have a squared value. So what we can do is say that, okay, so the modulus of x is therefore less than 3, which is true because both of these are positive, and so x also has to be positive, and so the modulus of x has to be less than 3. We can just take the modulus of each side of the inequality to confirm. Okay, so from this we're trying to consider x squared plus 2x plus 4 in some way. So now I'm going to make a proposal that if we have the modulus of this is less than or equal to taking the modulus of every component separately. So this is known as the triangle inequality, and intuitively it makes sense because, okay, this inside could be negative. Well, I guess not in our case, but in general this inside could be negative, whereas here we'll have each value being positive, so therefore it's greater or equal to this left hand side value. And so, okay, we know that this is true, so we know that x squared plus 2x plus 4 is less than or equal to 3 squared. Well, we don't need this anymore. 3 squared plus 6 plus 4. So we have x squared plus 2x plus 4 being less than 9 plus 6 plus 4, which is 19. Okay, so now all that's left to do is the same step as before. So this gives us an epsilon over 19. So now proof. Suppose epsilon is greater than 0, then if we have that minus, what did we use, 2? 2 is less than delta, then we have that x cubed minus 8 is less than epsilon. So setting delta to be equal to the minimum between 1 and epsilon over 19, or for the same reasons as before, because, okay, this assumption that delta is less than 1 led us to epsilon over 19, so we want to take the minimum value between 1 and epsilon over 19, because we don't want epsilon over 19 if we have a value greater than 1. Okay, so setting delta equal to the minimum of 1 and epsilon over 19, we have and so multiplying by x squared plus 2x plus 4, this is going to be less than epsilon over 19 multiplied by 19 from this here, and therefore we have x cubed minus 8 is less than epsilon as required. Hence we have the limit of x going to 2 of x cubed equal to 8. Okay, so now I will give the viewer some exercises to try. Exercises. Firstly, prove that the limit as x goes to 2 of x squared is equal to 4. Secondly, limit as x goes to 3 of x cubed equals 27. And then as a challenge exercise, write a little star to indicate it's a challenge. the limit as x goes to a of x to the n is equal to a to the n for n being a natural number, and we'll say a is greater than 1. Oh, yes. Thank you for watching. Bye bye.